Right, welcome to this new video. Remember that in the previous video, when we introduced the concept of eigenvalue and eigenvectors, we discussed the case of a 2 by 2 matrix, right? And now I want us to discuss the case of a 3 by 3, and with the difference that here you have repeated eigenvalue. What's happened when we have repeated eigenvalue in the case of a 3 by 3 or 4 by 4? How do you solve that? That's a question we want to answer, okay? In this example. Of course, there is a lot to say about that. We can cover it in this video, but in the tutorial question, we will solve one or two questions where you still have to deal with repeated eigenvalue, okay? So let's look at this example. We have this 3 by 3 matrix, and the question is find the eigenvalue and the eigenvector associated to this matrix M. So by definition, the determinant of A minus lambda I is equal 0. A minus lambda I is equal 0 is 1 minus lambda 1 1 0 3 minus lambda 2 0 2 3 minus lambda. Okay, this is equal 0. Then we have to find the characteristic equation. If we expand following the first row, we have 1 minus lambda bracket, this time this is 3 minus lambda square minus 4 is equal 0. At this stage, we want to factorize this, okay? If lambda is 1, then this will be 3 minus 1 square, and that is 4. 4 minus 4, 0. So this term we can factorize, but I can easily see that lambda equal 1 is a solution to this, okay? So we can first expand. This is lambda minus 1 bracket. As I say, so lambda equal 1 is a solution. Lambda minus 1, lambda minus 1, and lambda minus 5 is equal to 0. So from here, we obtain the two eigenvalues. So we have lambda equal 1 is the first eigenvalue, and lambda 2 is equal 5. Now let's look for the eigenvector. Eigenvector okay, so let's start with the simplest case, lambda 2. So for lambda equal 5, okay, we have to substitute here. We know m minus lambda, let's say 2i times x is equal 0, okay? Here we substitute. We know lambda is equal 5. This is minus 4, 0, 0. The second one is 1, 1. Here is minus 2, 2. And the third column here is 2 and minus 2. We multiply this by x1, x2, x3. This is equal 0 vectors, okay? So let's multiply this. We obtain minus 4x1 is equal 0. x1 minus 2x2 plus 2x3 is equal 0. x1 plus 2x2 minus 2x3 is also equal 0. All right, from the first equation, we see that x1 is equal 0. If you substitute here 0, 0, we remain with x1, x2 equal x3, right? So this means x2 is x3. This one also means x1 is equal 0. Then we fix the x2 and we choose x3. So this is, let's call it v1, okay? v1 is alpha times 0. If you fix, as I say, x3 is equal 1, then x2 is also 1. Here alpha is in R, and alpha must be different from 0. Okay, this is what we have for the first one. Now, what's happened for lambda? This is for lambda equal 5. For lambda equal 1. Again, we substitute here. lambda equal 1, we have 0, 0, 0, 1, 2, 2, 1, 2, 2. Multiply x1, x2, x3. This is 0 vector. So we can simplify this, given that the second and the third row are the same. So if we say the second row become second row minus the third row, then we have 0, 0, 0, 0, 0, 0, 1, 2, 2 times x1, x2, x3 is a 0 vector. All right, at this stage, as I say, this R2 become R2 minus R3. Okay, if you multiply, we have x1 plus 2, x2 plus 2x3. Let's solve this for x1. This is x1 is equal to minus 2x2 minus 2x3. Okay? So we fix x1, then we can give the value to x2 and x3. And this is x1, x2, x3 is the beta. x1, we start with this. This is minus 2, 1, 0 plus gamma. For the second one, we have minus 2, 0, 1. Okay? So we have the second vector and the third vector. Of course, beta and gamma all belong to R and different from 0. Beta is different from 0. Gamma is also different. 0. So we basically have our two vectors, okay? And these two vectors are independent. All right. This is all for this example, the repeated eigenvalue. So in the next video, we give you more example in the context of tutorial where you should be able to do the case of 3 repeated eigenvalue. This is the case of 2 repeated eigenvalue or even 4 repeated eigenvalues. Okay, thank you.